Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. Solve the following equation for real values of x, y, and z. And this is an equation problem that was asked in an algebra test at a high school in India. And the odd thing about this problem is usually when we are asked to solve an equation for a certain number of variables, we are given the same number of equations. So if you're asked in a problem to solve for values of 3 variables, the normal expectation is that we'll have 3 equations specified. And that's where this problem really stands out, because we are just given one equation, and you can see that it's kind of involves the squares of the variables. Then there are some product terms, right? X, y, y, z, and so on. So the question is, how do we solve, or is it even possible to solve this? So for one thing, we have to realize that when you have a problem like this, when there are squares of variables and you have multiple variables and it's asking for solving for real values, then there is kind of a little bit of rule or a trick that you can apply. And that rule basically is that if the sum of squares of 2 or more quantities. In this case, I've just taken like three quantities because we have 3 variables. So if s square plus b square plus c square is equal to 0 for real values of a, b, and c, and this could be actually n number of quantities. As long as they're real, and you have basically the sum of the squares of those quantities equal to 0, then each of those quantities individually should be equal to 0. So in this case, since s square plus b square plus c square is equal to 0, for this to be holding true for real values of a, b, and c, the only possibility is a is equal to b is equal to c is equal to 0. So from a scenario like this, from one single equation, we could potentially get 3 separate equations, because a equal to b equal to c equal to 0 essentially gives you now 3 equations. So the question is, can we reduce this given expression as the sum of squares of 3 quantities? And if we can do that, especially with the left hand side, and if we can equate that to 0, then we can potentially get 3 equations out of this single one equation that we're given. So with that in mind, we can start solving the problem. So this is what we are given, and one of the things that we note is there are some nice perfect square terms like 9x squared, and then 16 is a perfect square, but the other terms like 17y squared and 2z squared, they are not perfect square terms, but we can potentially break them up as sum of perfect square terms. So for example, 17y squared can be broken down as 16y squared plus y squared, and 2z squared could be broken down as z squared plus z squared. So once we note that, now we can start combining some of these terms strategically. So we start with 9x squared and combine that with y squared and 6xy. So these are the terms that I'm circling out in blue that I want to group together. And similarly, we can group together 16y squared, 8yz, and z squared. So those are in the green circle. And then we can group together z square, 8z, minus 8z, and 16. So those are in the red circle. So we can basically rewrite the same equation now by grouping the terms like this. So we can write 9x square and minus 6xy, we just break it down as 2 multiplied by 3x multiplied by y plus y square. So that's, one set of terms that I indicated in blue. Then we had the other set, which is 16y square, and then minus 8yz, we can break it down as 2 multiplied by 4y multiplied by z plus z square. And then the last set of groupings are in red, which involves z square, and then minus 8z, we broke it down as 2 multiplied by z multiplied by 4 plus 16. And then if you look at, the three terms which are in one color, they actually, conform to that formula of a minus b whole square. So we know that a minus b whole square is equal to a square minus 2ab plus b square. So we can write each of those three terms that are of one color as, a minus b whole square, like the form a minus b whole square. So for example, the first term could be written as, the first three terms, which are in blue, could be now grouped together as 3x minus y whole square. Similarly, the second set of terms, which are in green, they can be grouped together as 4y minus z whole square. And the third set of terms, which are in red, could be grouped as z minus 4 whole square. And now we have basically, reduced our given equation to sum of three squares on the left-hand side. And the right-hand side is still 0. So we have essentially a form of a square plus b square plus c square is equal to 0. And for that to hold true, we know that each of those terms individually, they must be equal to 0. So once we have that, now we have essentially, three equations, and the problem actually becomes very simple because, z is equal to 4. So z minus 4 is equal to 0, so that makes z equal to 4. And then 4y minus z is equal to 0, which makes 4y is equal to z, and then we can write y as z divided by 4, and since z is 1, y becomes 4 by 4 is equal to 1. And then 3x minus y equal to 0, which makes 3x is equal to y, from which x becomes y by 3, which is 1/3, because y is equal to 1. So the final solution that we get, and this is only, the real values, the real value solutions, right? X is equal to 1/3, y equal to 1, and z equal to 4. So using this trick, we can basically solve for three unique variables from only one given equation.